Welcome to Quantum Mathematics. In this lecture, we will study about what is a function and types of functions. We will see some examples, some notations, and we will also discuss how a function is different from a relation. So, first, function. If we want to study functions, first we need two non-empty set. So let A and B be non-empty sets. A function from set A to set B is a specific relation in which every element of A and this set A is called domain. We will call it domain. Element of A which is domain is mapped or related to unique element of the set B which we will call codomain. So there are two sets, the first one from where we are defining the function, and the second set is the function which takes some value from the first set and maps to some value in the second set. So the first set is called domain and the second set is called codomain. And if we try to draw some pictorial diagram, so here is our set A and this is set B. Now as I told you, the set A is called domain. So this means the elements which are inputs and the elements which are outputs are from different sets, though in some situation both sets may be same, like if we want to define a function from the set of real numbers to the set of real numbers. So here domain and codomain both are same. But in general, domain is the set from which we are defining the function and codomain is the set where the function takes the values. So A is called domain and B is called codomain. Now we are defining a function f which takes some value x in the first set and it gets mapped to the second set, and that mapping must be unique. So this is the very crucial difference between what is a function and what is a relation. So I will discuss here. So in function, the element x in this first set gets mapped to a unique element of B. So the word unique refers to that if suppose we have an element here B1 and second element B2 in the codomain, so this should not happen. What should not happen? Any particular element or general element x cannot get mapped to two different elements in B. Otherwise, this will be not a function. Otherwise, it is called a relation, not a function. So, if x is mapped only at a unique element B1 and it does not gets any other value in B2, then and only then it is called a function. So, if there is any other element in the domain set y and it gets mapped to B2, there is no problem. But the main difference here is that first set, when we are defining function, any element from the domain can mapped can get a mapping to a unique element of the codomain. Now I will erase it. So as I told you, no, let me resize it. So this is a very crucial difference between what a function is and what a relation is. Now I will write it again here. Oh, I have written something here. Now, so first we will learn notation. I will discuss it again. So notation is like f, and this is colon, and then the first set which is domain, and then an arrow to the second set b, which is codomain. So this is written like this: f is a function from the set A to set B. This is read like this. So f is a function from the domain to codomain. Now for every x belongs to A, I am writing the definition in notation. For every x belongs to A, fx belongs to B. So what we are saying that fx is the image or the value of this element x in the domain. So the input is x. So what is x? X is input, and which is an element of the domain, set A, which is domain, and fx is output, which belongs to the set B, which is codomain. So I think now it might have been clear to you that function is like a machine. So f, what is f? It is like a machine in which we give some input, and input comes from where? From the domain, and it gives you some output, and output means the codomain. So the function is like a machine in which we give some input from a set which is called domain, and it gives some values or a unique value, we can say, in the output, and output is related or is an element of the set B, which is codomain. So now I will clear some differences between a relation and a function. How not every relation can be a function. So for that, suppose we have a set here. First I am going to define take an example of a relation. Suppose there are few elements 1, 2, 3 and 4, and here A, B, C. If one gets mapped to A and 2 gets mapped to B, but 2 also gets mapped to C, then this particular of mapping is not a function. So because why it is not a function? Because the element 2 has 2 different values in the set B. That means one element from the domain gets 2 values in the codomain. Therefore it must not be a function, because for this mapping to be a function, B must have like this. So again, this is domain, this is codomain. If an element 1, let me write it, 2, 3 and 4. If the mapping is like this, also here is also one more point I missed. Any element from the domain set cannot be left unmapped. So here we see that these two elements 3 and 4 are not getting any map in the set B in codomain. That means they are not taking any values. Therefore, it must not be a function. So what a function is? So function is like this. Element 1 gets mapped to A, element 2 gets mapped to B, 3 gets mapped to C, and 4 gets mapped to again A. So now in the domain in this set 1, 2, 3 and 4, all 4 elements are having values in this set B, which is codomain. But we can also see that 1 only gets mapped to A, not B, not C. Similarly, 2 also gets mapped to B, not A, not C. So 1 only goes to A, 2 only goes to B. Now 3 only goes to C and 4 only goes to A. So now we are seeing that for 1 there is only one element in this set B, and for 2 there is only one element in set B. So we can see that any element of the domain set has unique value in the codomain set, and also no element of the domain is left unmapped. So we can see that 1, 2, 3 and 4, all 4 elements have images in this set codomain B, and there is no discrepancy in the mapping. That means 1 has only one value, that means unique value, 2 has only unique value B, 3 also has unique value C, 4 also has unique value A. So this type of relation where every element of A gets mapped or gets value uniquely in B, this type of relation is called a function. So function is a very specific kind of relation in which we are restricting some conditions. So first restriction is no element of the domain must be left unmapped. Second restriction is every element of A can get only a single value in the codomain B. So now I think you might have understood what a function is. Now we will take some example. So take an example. So the example is, let A, that means our domain is these points 1, 2, 3, 4, 5, 6, 8, and codomain is again 1, 2, 3, 4, 5, 6, 8, 9 and 10. Now we define a function from A to B, and we define it like this. This is written as fx is equal x square. So here the machine, how it works, the input is any element from this set A, and the input comes in the output comes in the set B, but the machine f changes is like it is squaring the number. So if we have any element x, it gets mapped to its square. For that, now we will test whether this is a function or not. So for that we will check all the numbers. Now first, f of what is the first element in the domain? 1. So f of 1 means 1 square, which is also 1, and 1 is in the set B. We can see that belongs to B. So this follows the machine. Second, if we select 2 from the domain, then f of 2 becomes 2 square, which is 4, and 4 is also in the set B. We can see that here. Now f of 3, because 3 is also in the domain, so the f of 3 becomes 3 square, which is 9. Now here 9 is also in the codomain, so there is no problem, 9 belongs to B. But as we select the fourth element, which is none other than 4 in the domain, 4 gets mapped to 4 square, which is 16, and 16 is not an element in B. That means the element 4 has no image in the codomain. And afterwards we can also see that f5, f6 and let me see, f8. So f8, these also f4. So f4, f5, f6, f7, f8, these elements do not have any image in the codomain. These do not belong to B. That means अगर हम इनको एक सेट से रिप्रेजेंट करें, now I have switched to my native language, belong to B. So we have element 1, 2, 3, 4, 5, 6, 7 and 8. So 1 is having a mapping, 2 is having a mapping, 3 also have a map, 4 and 5 and 6 and 7 and 8. These elements do not have a map. 1 has a map here, 1. 2 has map 4, 3 has map 9. But these arrows do not meet any point here, because those elements are not even in the set. So that means f is not a function. How it is not a function? Because it broke the first restriction. And what was the first restriction? It was that every element of domain must get mapped to codomain, to some unique element in codomain. So there is not even a question of uniqueness. Uniqueness does not fail here. But what fails here? Not every element gets mapped. So we see that f4, f5, f6, f7, f8 do not belong to B, because this set is small. It does not contain the images of 4, 5, 6, 7 and 8, and that are 16, 25, 36, 49 and 64. Therefore this f function, this f mapping is not a function. So now I will give you a problem to test that you understood function or not. So for that I have given you a set 1, 2, 3 and up to 10, and set B 1, 2, 3 and up to 100. Now you have to test the same machine whether this is a function or not. So if we define it fx equal x square, and let me rephrase it, where is x coming from? For every x belongs to A, fx is x square belongs to B. So now this is a problem I am leaving to you. You have to test whether this, for these set A and B, where A is domain and B is codomain, this machine fx is equal x square, this relation is a function or not. You have to test it and pin down in the comment your answers. Now as we see that we have domain, also codomain. Now there is another word which is called range. So what is a range? So suppose we have a set A and this is set B, which is codomain, but not every element of B has a pre-image in A. That means if whole of this set A gets mapped to a smaller subset of B, then this smaller subset is called range. So what is a range? Range is a subset of codomain. First point. Second, in range only those elements of B are kept which are values or images of some element of the domain. So what is a range? Range is a subset of codomain, and in range only those elements of B are kept or can be written which are values or images of some elements of A. That means if we collect all the images of the elements of domain, then this set is called range, and this is a subset of codomain. For that, suppose we have a function f from set A to B, where A is defined as 1, 2, 3, 4 and B is 1, 2, 3, 4 and up to 50. So we have 50 natural number from starting, and A has only 4 natural number 1, 2, 3, 4, and function is same as earlier, fx is equal x square. Now we have to find the range of this function. Now again I am calling it a function, that means it is a function. You can also test it whether this relation is a function or not. So it is a function, you have to test it. It is also another problem for you. Now if we want to select all the values of this set A, so what f1 is? F1 is 1 square, which is 1. F2, so F2 is 2 square, which is 4. F3 is 3 square, which is 9, and F4 is 4 square, which is 16. So what are the values? 1, 4, 9 and 16. So this set S is a subset of the codomain B, but it only contains the images of this function fx is equal x square. So this set S is called, range of f, range of this function f, because in this set only those elements of B are written which are images of elements in the domain which is A. So 1, 2, 3, 4 are elements of the set A, and 1, 4, 9, 16 are the elements of the set B. So this set S is called range of this function f. So now I think you must have understood what a function is, what is domain, what is codomain. These are terminology. The set on which we define the function is called domain. The set on which the function takes values are called codomain, and the set of all values in the codomain is a subset of the codomain, and it is called range of that that function. So I think this is sufficient for this video. In next lecture I will talk about types of functions, and we will take some examples, and I will also give you some problems. So thanks for watching. I will request you to please share it with all the science students, mathematics students, or whoever wants to learn about mathematics. Thank you.